Hello my friends and welcome back to the channel Heavy Machinery. Join us today as we explore the fascinating journey of copper, from mining and extraction to smelting and crafting durable, high-quality copper parts. Stay tuned for this incredible process. Copper, one of the most versatile and widely used metals, plays a crucial role in various industries due to its excellent electrical conductivity, corrosion resistance, and malleability. Exploration and discovery. Identifying copper ore, the first step in copper mining, begins with the exploration phase. Geologists and surveyors conduct detailed studies to identify copper ore deposits within the Earth's crust. The most commonly mined copper ores are chalcopyrite, bornite, and malachite, with chalcopyrite making up the majority of the world's copper supply. Geologists use various techniques to locate potential mining sites, including geological surveys, satellite imagery, and exploratory drilling. Once a promising location is identified, core samples are extracted from the ground for analysis. These samples provide insight into the concentration of copper in the deposit, helping determine whether the site is economically viable for mining. Drilling and blasting. Preparing for extraction. Once a copper deposit is identified, mining companies begin preparing the site for extraction. The process typically involves open pit or underground mining, depending on the deposit's depth. In open pit mining, large sections of land are cleared, and massive drilling equipment creates holes for explosives. Controlled blasting breaks up the rock to expose the copper-bearing ore, which is then transported by large trucks to the processing facilities. For underground mining, tunnels are drilled deep into the Earth's surface, with miners removing the ore from beneath the ground. Ore extraction. Collecting copper-bearing minerals. After the initial blasting phase, copper ore is extracted from the mine and transported to a nearby processing plant. The ore contains only a small percentage of copper, typically between 0.5% and 2%, while the remainder consists of other minerals and rock materials known as gangue. In both open pit and underground mining operations, the extracted ore is crushed into smaller, more manageable pieces. This allows for easier handling and further processing in the upcoming stages. Giant crushers, often powered by electricity or diesel engines, reduce the ore to the size of gravel. Crushing and grinding. Reducing ore to fine particles. Once the ore is transported to the crushing plant, it undergoes several stages of crushing and grinding to break down the rock further and liberate the copper minerals. The crushed ore is fed into large grinding mills, which consist of rotating drums filled with steel balls or rods. As the drums rotate, the ore is pulverized into a fine powder, which allows for greater surface area exposure during the flotation process. The goal at this stage is to reduce the copper ore to a size small enough for the subsequent chemical separation process. Flotation is one of the most critical processes in copper extraction. It separates valuable copper minerals from non-valuable materials, gangue. This is achieved through a series of chemical reactions and physical processes. In flotation, the ground copper ore slurry is mixed with water and chemicals called collectors, which help the copper minerals attach to air bubbles in a flotation cell. As the slurry is agitated, the copper-rich bubbles rise to the surface, where they are skimmed off. The remaining material, known as tailings, is discarded. The copper concentrate, which contains about 20 to 30% copper, is then sent for further processing. Flotation is an efficient method for recovering copper from low-grade ores. However, it requires significant amounts of water and energy, and the disposal of tailings can pose environmental challenges. Modern mining companies are increasingly adopting tailings management systems to minimize their environmental footprint. After flotation, the copper concentrate undergoes smelting, a high-temperature process that separates the metal from impurities. Smelting is conducted in furnaces, where the copper concentrate is heated to around 1,200 degrees Celsius, 2,200 degrees Fahrenheit. This causes the copper sulfide minerals to break down, releasing sulfur dioxide gas and leaving behind a molten copper-rich material known as matte. The matte, which is about 60 to 70% copper, is then subjected to further smelting in a converter furnace, where it is combined with oxygen to remove any remaining sulfur and iron. The result is blister copper, a product that is approximately 98 to 99% pure. Blister copper still contains impurities, so it must be further refined to produce high-purity copper, which is required for most applications, especially in the electronics industry. In fire refining, blister copper is heated in an anode furnace, where air is blown through the molten copper to oxidize and remove any remaining impurities. The refined copper is then cast into large slabs called anodes, which contain about 99% pure copper. The most common method of refining copper is electrolytic refining. In this process, copper anodes are immersed in a tank filled with an acidic copper sulfate solution. An electric current is passed through the solution, causing the copper to dissolve from the anode and redeposit onto a cathode as high-purity copper, usually 99.99% pure. The impurities, including gold and silver, settle at the bottom of the tank as anode slimes and can be recovered and sold as byproducts. The end result of electrolytic refining is high-purity copper cathodes, which are ready to be shaped into final products. Further processing and manufacturing the refined copper cathodes are now ready to be transformed into a wide array of products. This final step involves shaping the copper into usable forms through processes such as casting, extrusion, rolling, and drawing. One of the most common uses for copper is in electrical wiring. In wire drawing, copper cathodes are melted down and drawn into thin, conductive wires. This process involves stretching the copper through a series of dies to reduce its diameter and increase its length. Copper is also cast into various shapes, such as rods, bars, tubes, and sheets. In casting, molten copper is poured into molds and allowed to cool. Extrusion involves forcing molten copper through a die to create long, uniform shapes like pipes or rods. These products are used in plumbing, construction, and other industries. Rolling is used to produce thin copper sheets, plates, and strips. The copper is heated and passed through a series of rolling mills, where it is gradually flattened and stretched into thin sheets. These sheets are used in roofing, gutters, and electronic components. Copper is unique among metals, capable of being recycled over and over again without losing its inherent quality. This infinite recyclability is one of copper's greatest environmental advantages, making it an essential player in creating a more sustainable world. Copper recycling not only conserves a valuable resource, but also significantly reduces the energy and environmental impact associated with extracting and processing new copper from the earth. One of the most significant environmental benefits of copper recycling is its efficiency. The process uses up to 85% less energy than mining and refining new copper from ore. This energy savings translates to a lower carbon footprint and a reduction in greenhouse gas emissions, helping to mitigate the environmental impact of resource extraction. Additionally, recycling minimizes the amount of copper that would otherwise end up in landfills, reducing waste and preserving natural resources for future generations. Recycled copper can be used directly or blended with newly mined copper to meet the specific quality requirements of manufacturers, making the material highly versatile. This circular approach, where products are continually cycled back into use, embodies the concept of closing the loop, a key principle of sustainable resource management. By embracing copper recycling, industries and consumers alike contribute to a more energy-efficient, resource-conserving future, where the value of materials is maximized and the environmental impact is minimized.